several things affect how a gas behaves. There's temperature, which we'll represent with a capital T, volume with a capital V, the number of particles in the container, and the pressure, which is a capital P. Pressure is the amount of force distributed over an area. So to figure out pressure, I would take the force, which we measure in newtons, and divide it by the area, which we measure in meters squared. This would give us a Pascal. So that is 1 Newton per meter squared, and I represent that with capital P, lowercase a. So a Pascal is a unit of pressure. Other units of pressure are atmospheres, which I represent with ATM, torr, which doesn't have an abbreviation, it's still torr, and millimeters of mercury, which is mm of Hg, since Hg is mercury. Whenever I adjust one of these four things, I'm either going to increase the amount of collisions between those particles or decrease the amount of collisions between those particles. The more collisions I have, the more pressure there will be. So this means that anytime that the particles are colliding with each other or with the walls of the container, that's going to cause more pressure. Less collisions would mean less pressure. So because of those four things, we have some laws that apply to gases. The first law is Boyle's law, which tells us that if I decrease the volume of a gas, so if I put it in a smaller container, it will increase the pressure. That's because there's less room for the particles to move around, which means there will be more collisions, and of course we know that means more pressure. If I increase the volume, or put it into a larger container, I'm going to decrease the pressure because there's more room for the particles to move around. There will be less collisions, which means less pressure. I can put this idea into an equation, which is P1 times V1 equals P2 times V2. Anytime I see a number 1 as a subscript, that means that's what the initial pressure or volume was. Initial just means what it was at the beginning of our story or of our scenario. Anytime I see a 2, that means that that's what it was at the end of the scenario, or that's what the final pressure or volume is. So if I do an example, I have this problem. A gas has a volume of 125 milliliters at 1.2 atm, which is atmospheres. What is its volume at 0.98 atmospheres? So I started at a certain volume and pressure, and I'm ending at a certain pressure. I have to figure out what the volume is. So just like I did for my density problems, I need to show my work. So number 1, this is the equation that I'm using. If I just have volumes and pressures in my problem, then I only have pressures and volumes in my equation, so this is Boyle's law. Number 2, I need to use my algebra skills to rearrange this because I don't know all 4 of these things. I only know 3 of them. The one that I don't know is the volume at the end of our scenario. So to get that by itself, I'm going to divide it by P2 because right now it's being multiplied by P2. So I do the opposite by dividing on both sides. P2 over P2 is 1. So I have an equation now that I can plug the numbers into. Number 3, I'm going to list what those numbers are. So I scan and I see that the first value I come to is 125 milliliters. That's the volume at the beginning of the scenario. The pressure at the beginning of the scenario is 1.2 atmospheres, so that's my P1. The pressure I'm changing it to is 0.98 atm. Fourth, I'm going to plug those numbers into the equation I came up with here. And fifth, I just put that into my calculator, which my calculator tells me is 231. I have to have the correct unit as well. So I know that I'm trying to figure out volume. So all I have to do is look at what unit did we use for volume at the beginning. We used milliliters, so that's the unit we would have for our answer. Another gas law is Charles's law, which is about temperature and volume. If I increase the temperature, I end up increasing the volume. So there's more kinetic energy anytime I increase the temperature, which means they're moving faster. and that is going to cause more collisions, and that's going to cause it to spread out. So this is more for a case like if I have a gas in a balloon, where if I increase the pressure, it'll cause the balloon to expand. If I decrease the temperature, that means there's less kinetic energy, less collisions, so there will not be pushing out with as much pressure, so the balloon would get smaller or have less volume. My equation for this is T1 V2 equals T2 V1. Notice that the 2 and the 1 are not on the same side like they were before. When I have these problems, the temperature has to be in the unit of Kelvin. So for Celsius, all I have to do is add 273 to the temperature in degrees Celsius to get what it would be in Kelvin. And then 0 Kelvin is what we call absolute zero. This is a temperature at which scientists believe that all motion of the particles would completely stop, which we know from our kinetic theory of matter shouldn't technically happen. So basically the idea is that absolute zero is extremely cold. So my example, a gas has a volume of 250 milliliters at 295 Kelvin. What is its volume at 273 Kelvin? First, I write my equation. All I have up here are volumes and temperatures. So this is the equation I'm going to use. Number 2, I need to rearrange it. The thing I don't know is the volume at the end, or V2. So I see it's being multiplied by T1, so I just divide by T1 on both sides to get my equation. Number 3, all I have to do is write out what values I have and decide which one is V1 and which one is T1. So the first volume they gave me happens to be V1, so 250 milliliters, and it is 250 milliliters at this temperature, so that's my T1, and then I'm changing the temperature to 273 Kelvin, so that's my T2. I plug my values in to the equation I came up with here. My calculator tells me it's 231, and I make sure I have the correct unit. I know I'm looking for a volume, so I look at what volume was used before, milliliters, so that's what I have for my answer as well. My last law is called the combined gas law, which literally combines the two laws that we just discussed. So I have P1V1 T2 equals P2V2 T1. This is sometimes overwhelming to students because there are a lot more numbers, but the process is still the same. So let's go through one. A 300 milliliter balloon at 1.1 atmospheres and 300 Kelvin is taken outside where it is 0.9 atmospheres and 252 Kelvin. What is the new volume of the balloon? As soon as I see that there are 5 numbers up here, I know I'm using the combined gas law. So that's my equation. Number 2, I'm rearranging it, so the thing I don't know is the new volume, or V2. So I look at what's being done to it. It's being multiplied by P2 and T1. So I'm going to divide by P2 and T1 on both sides. P2 over P2 is 1. T1 over T1 is 1. So this is the equation I will use. Third, I write out the numbers that I know. So the volume at the beginning is 300, so that's my V1. It's at this pressure, so that is P1. And it's at this temperature, so that's T1. Then I take it to a new environment where the pressure is 0.9, so that's my P2. And the new temperature is 252 Kelvin, so that's T2. I plug those numbers in to the equation I came up with here, and it looks like this. I put that into my calculator carefully because I need to make sure that my calculator does the order of operations correctly. So if I were you, I would calculate the top first and then write that down and then divide it by this times this. So do them as separate parts just to make sure you get the correct answer. So once I do that, I get 308, and again, I'm looking for a volume, so I look at what volume was used before, milliliters, so that's the volume that I would have at the end.